Happy morning, my dear children. Today we are going to discuss about the P block elements 2, that is unit 3. Today our portion, the reactions of metals with nitric acid. It can be explained in 3 steps. 3 steps, that is a page number 62. Please all of you turn over the page number 62. They are having 3 steps reaction. One is primary reaction. Second one is a secondary reaction. The third one is the tertiary reactions. Okay. And we are going to discuss about the examples also. What is about the primary reaction? That is, one of the metal reacts with nitric acid. We get metal nitrates and also a nascent hydrogen. Okay. Nascent, a single nascent hydrogen. This nascent hydrogen again reacts with nitric acid. That is about the secondary reaction. One of the nascent hydrogen again reacts with the nitric acid. We get four different reduction product. What are the reduction product? One is about the nitrous acid. Second one hydroxylamine. Third one ammonia. Fourth one hyponitrous acid. Next about the tertiary, that is the third step. The secondary product either may decompose or react to give a final products. Okay. We can discuss one by one, also with the example. One of the example, how the primary reactions is going on, secondary reactions is going on, and about the tertiary reactions, and also about the what is the overall reactions. We are learning about the 2 example. Okay. Please all of you learn one by one. Okay. We can write all the equations. Please all of you take the note. Now we can discuss about that. Nitric acid reacts with the metal. What happens? Nitric acid reacts with the metal. One of the important point. Actually, it is an yesterday topic. Am I right? Due to the insufficient time, I skipped that portion. Am I right? Yesterday. So please all of you learn carefully. Here, what is the reactions means? Nitric acid reacts with the metal. Have 3 different steps. The first step is a primary step. Second is about the secondary, and third is about the tertiary step. Okay, am I right? So 3 steps we have nitric acid undergoing reacting. What is the first reaction means? First step means nitric acid reacts with the metal to form metal nitrate and release a nascent hydrogen. Can you understand, my dear children? Nitric acid reacts with the metal to form metal nitrates and also release a nascent hydrogen, a single nitrogen. That's the first step. What is about the nascent hydrogen? That means it is only one hydrogen atom. That is atomic state. It represents in an atomic state. I'm right. It is enclosed in a square bracket like that. Okay, it's a more reactive, highly energetic, as we are comparing hydrogen molecule. I'm right. Can you understand, my dear children? One of the highly reactive, more reactive, high energetic, as we are comparing to hydrogen molecule. So there is a nascent hydrogen. What is about the second reaction? Secondary reactions means in the primary reactions we are adding excess nitric acid to the metal. In that reactions there have some unreactive nitric acid. Am I right? Some of the unreactive nitric acid again reacts with then this nascent hydrogen. We get one of the products, some of the products. It may be a nitrous acid, or maybe a hydroxylamine, or maybe a ammonia, or maybe a hyponitrous acid, like that. Some of the product we get. Okay, can you understand? The nascent hydrogen reacts with the unreactive nitric acid. The nascent hydrogen produce the reduction product, one of the some reduction product. Reduction product means you know that one, the nitrous acid. What is the formula of nitrous acid? HNO2. hydroxylamine NH2OH, ammonia, hyponitrous acid, that is H2N2O2. This formula today only we are learning. So how to write the formula also, try to learn the formula also, very important. The third one, tertiary reactions. What is about the tertiary reaction? The secondary reaction, we get some product. Which are the product we get? Reduction product, nitrous acid, am I right? Hyponitrous acid, ammonia. These are some product. This product either may be decompose or may be react with to form the final product. That is, in the secondary reaction we get on product, this product either decompose or react to give final product. This is about the tertiary reaction. We can discuss about the examples with an example. Before that, we have to learn the reactions, primary reactions, secondary reactions, and about the tertiary reactions. Okay. The first one, metal. I am taking just M refers to metal. Am I right? What is here? M means metal. So I'm just going to give you an example. M, that is a metal, reacts with nitric acid. What is the formula? HNO3 gives this metal combines with NO3. The metal combines with NO3. We get MnO3. That's about the metal nitrates. Metal nitrates. Okay. MnO3. Okay. Plus here the releasing of nascent hydrogen. Here having only one hydrogen. So we are writing nascent hydrogen. We are enclosed in a square bracket. What is about the nascent hydrogen, my dear children? Nascent hydrogen. It is expressed in atomic state. Highly reactive, more reactive as we are comparing hydrogen. High energetic. Am I right? So don't forget that. So I think that the equation is, we are saying the equation is balanced. Am I right? So next one. What is a secondary reaction? That means the nascent hydrogen reacts with unreacted nitric acid. We get the reduction products. Okay. First I am taking nitric acid. What is the formula of nitric acid? HNO3. This reacts with nascent hydrogen. One of the nascent hydrogen gives here this nitric acid. I am going to write like that. H2ONO2. Am I right? Shall I write like that? H2NO2, HONO2. This OH combines with this one of the nascent hydrogen. We get, what is the product here? Water molecules. Am I right? Water molecules plus, here, what's the remaining here? What is remaining here? HNO2. So how can you balance the reactions? So we are getting one of the reduction products, HNO2, that is a nitric acid is converted into nitrous acid and also water molecules. And also we get what? Water molecules. Here, how can we balance the reaction? The product side, we have 3 hydrogen. Am I right? 3 hydrogen. The reactant side, we have only 2 hydrogen. If we are making here two nascent hydrogen means now the equation is balanced. Am I right? Yes or no? Okay. Second step. Nitric acid, HNO3, reacts with nascent hydrogen, enclosed in a square bracket, we can do like that. Gives, what is the product here? Hydroxylamine. What is the formula? NH2OH plus hydrogen combines with oxygen. Hydrogen combines with oxygen to form water molecules. Okay. How can you balance the equation. Here having 3 oxygen atom, here that is a reactant side having 3 oxygen atom, the product side only having 2 oxygen atom, am I right? So first I am making here 2, water molecule is 2, water molecules I am giving 2 moles. So how can we solve this one? 2 plus 2, 4, 4 plus 1, 5, am I right? So, sorry, 2 plus 2, 4, 4 plus 2, 6, 6 plus 1, 7. Okay, out of this 7, here, if you are making the nascent hydrogen atom like the 6 means 6 plus 1 is equal to 7. Yes or no? Because here the reactant side having only 3 oxygen atom, the product side only having 3 oxygen atom. The reactant side having only 1 nitrogen atom, the product side also having only 1 nitrogen atom. The problem is only about the hydrogen. So the reactant side they are having 4 plus 3, 7 hydrogen atom. So if you are making here 6, 6 means now the equation is balanced. Yes or no? Next one. Nitric acid again reacts with nascent hydrogen atom. We get ammonia. Another one reduction product is about the ammonia. We get the 4 product. Don't forget that. Which are the product? Nitrous acid, hydroxylamine, ammonia, and one more product, very, very important product, hyponitrous acid. What is the formula? H2N2O2. Don't forget that. I will ask the question. Okay. Ammonia. And also we get hydrogen combines the oxygen to form water molecules. We know that one. Am I right? So how can we balance the equation? Balance the equation is very, very important. Nitric acid, how much oxygen is there, my dear children? How much oxygen is there? 3 oxygen atom. Am I right? Nitric acid. What about the product side? They are having only 1 oxygen atom. So if you are making 3 water molecules, means oxygen is balanced. Am I right? Yes or no? Okay, oxygen atom is balanced. What about the nitrogen? Nitrogen is also balanced. What about the hydrogen? So how can you count the hydrogen means? 3 2s are 6, am I right? 6 plus 3, 9 hydrogen atom is in the product side. What about the reactant side? Reactant side, if you are making this hydrogen, nascent hydrogen, we are giving 8 means 8 plus 1 is 9. Yes or no? Okay. Next about, what is the next one? Nitrous acid, HNO2, reacts with again nascent hydrogen. We get hyponitrous acid. Don't forget that. What is the formula? H2N2O2. H2N2O2 plus. We know that on the hydrogen combines to oxygen. We get what is the product? Water molecules. So we get water molecules. Now, how can we easily balance the reactions? First, please count here how much nitrogen having in the hyponitrous acid. How much nitrogen having? 2 nitrogen. So, make the reactant side 2. Now, nitrogen is balanced. Am I right? What about the hydrogen? Before that, we can count the oxygen also. Oxygen. In the reactant side, how much oxygen is there? 2 into 3 is equal to 6. Am I right? 2 into 3 is equal to 6. But the product side, here, already having 2. The water having 1. So, how can we easily balance? Means if you are making 4 means, 4 water molecules means, 4 plus 2 is equal to 6. So, oxygen is balanced. Yes or no? Next, we can count the hydrogen. How much hydrogen is there? 4 into 2 is equal to 8 plus this 2. We get 10 hydrogen. Yes or no? After 10, how much over here the reactant side? 2 over. Then if you are making 8 means this also balance. Am I right, my dear children? Okay, I hope that you maybe understand this one. If you are taking 1 times return practice means it is very easy for you. Okay? So try to balance the equation. So, primary reaction, first one, the metal forms metal nitrates with nitric acid and also release nascent hydrogen. Secondary reaction, the nascent hydrogen produces the reduction products with unreactive nitric acid which is present in the primary reaction. What is about the tertiary reaction? Tertiary reaction, that means in the secondary reaction, we get some reduction products. This either may be decomposed or may be react to give final products. Am I right? First, we can be write the decomposition reaction. Decompose, this is the third step. Primary reaction is the first step. Secondary reaction is the second step. Tertiary reaction is the third step. Am I right? So here I am taking nitric acid undergoes a decomposition. HNO3 undergoes a decomposition. What is the product here? Nitric acid is decomposed. We know that one. Nitrous acid. What is the formula here? HNO2. Nitrous acid. And also the nitrogen combines with oxygen. Oxygen we get nitric oxide. That is NO plus H2O. Okay. What is about this product name? Nitrous acid, nitric oxide. Oxide, don't forget that. How can we balance the equation? My dear children, first we are balance the equation. You have to count the number of hydrogen in the product side. Number of hydrogen. How much hydrogen is there? Here having 2 hydrogen, the water having 2 hydrogen, and here I am also having 1 hydrogen. So 2 plus 1 is equal to 3. Am I right? So make it 3 on the reactant side. Yes or no? So can you understand, my dear children? Reactant side. The product side they are having 2 plus 3 hydrogen. 2 plus 1, 3 hydrogen. The reactant side make it 3. Now the reaction, now the equation is balanced. Second reaction, I am taking this nitrous acid. This nitrous acid undergoes decomposition. Nitrous. What is the formula here? HNO2 undergoes decomposition. We get N2O3 plus H2O. Am I right? What is N2O3? N2 means dinitrogen. Am I right? O3 means trioxide. Okay. Can you understand? Dinitrogen trioxide. What is the formula name? Tell me. Dinitrogen trioxide. And also we get water molecules. Don't forget that. So how can you balance the equation? Come to the product side. How much nitrogen they are having, dear children? How much in nitrogen? N2. Am I right? N2. That means 2 nitrogen. So the reactant side also make it 2 here. Now the equation is balanced. Yes or no? Next, third reduction product from the secondary reaction I am taking hyponitrous acid. What is the formula? H2N2O2. Hyponitrous acid undergoes decomposition. We get nitrous oxide, that is N2O, nitrous oxide, and also water molecules, H2O. Dear children, what is about the nitrous oxide? It's one of the laughing gas, okay? Laughing gas, nitrous oxide, okay? Okay, how can you balance the equation? Nitrogen, in the product side nitrogen, 2, reactant side also 2, hydrogen also product side 2, reactant side also 2, oxygen also product side 2, reactant side also 2. Now the equation is balanced. Am I right? This is about the decomposition reaction. Decomposition means the reactant undergoes dividing or splitting like that, we can be say. Okay, division like that. Okay. Next one is about that. Reactions of secondary products. That means about that the nitrous oxide. I am taking here the nitrous acid with the secondary product, I am taking the three important product. One is about the ammonia. Second one is about the hydroxylamine. Third one is about the nitric acid. These three reactants I am taking. Sorry, three products I am taking. First, I am reacting with nitrous acid. There is a reactions of secondary product. What happens? The secondary product on react with. Am I right? React with nitrous acid. Okay, first one I am taking. Nitrous acid. What is the formula? HNO2. Reacts with ammonia. What is the formula? NH3. Am I right? NH3 gives our expected product means they are having two nitrogen. Am I right? Two, we get nitrogen molecule, and also the hydrogen combines with oxygen, we get water molecules. How can you balance the equation? First one is about the nitrous acid, HNO2. Nitrous acid on reacts with ammonia, we get nitrogen, dinitrogen and water molecules. Here, how much oxygen having in the reactant side? Can you count? How much oxygen? 2 oxygen. So the products will also make it 2 water molecules. Now the equation is balanced. Am I right? Next one. Nitrous acid reacts with the hydroxylamine. Hydroxylamine, all of you know that one. What is the formula? NH2OH. NH2OH, we get N2O. What is N2O? Laughing gas. Don't forget that. Nitrous oxide. Nitrous oxide, N2O plus water molecules. What is the importance of laughing gas? Anybody know that one? Please reply me, okay? What is about if you are inhale the nitrous oxide gas, what happened? You tell me, okay? In the assignment section, okay? Here, nitric acid on reacts with hydroxylamine, we get N2O, that is a nitrous oxide, and also we get water molecule. How can you balance the equation? The reactant side. In the reactant side, they are having 3 oxygen atoms, HNO2. Am I right? HNO2, nitrous oxide, nitrous acid, HNO2 on reacts with hydroxylamine, that is NH2OH. We get N2O and water molecules. The reactant side, we have 3 oxygen atoms. So the product side also make it 3 oxygen atom. So water having H2O. If you are making the water 2 means the oxygen is balanced. What about the hydrogen? Hydrogen is there having 4. Here also having 3 plus 1, 4. Okay, now the equation is balanced. The last reaction. Nitrous acid on reacts with the nitric acid. Nitrous acid. What is the formula of nitrous acid? HNO2. It on reacts with nitrous acid. Sorry, nitric acid. Okay, nitrous, nitric. Nitrous means HNO2. Nitric means HNO3. So I am taking nitrous acid first. HNO2 plus HNO3 gives, we get nitrogen dioxide. What is the product name? NO2 means nitrogen dioxide. And also we get water molecule. How can you balance the equation? The reactant side, they are having 2 nitrogen. So make it 2 NO2. So now the equation is balanced. Am I right, my dear children? So I told that what happens, the metal reacts with the nitric acid, we get the different products. That is about that we have the 3 steps. What are the 3 steps here? The primary steps, that is a primary reaction. Second step is about the secondary reaction. Third step is about the tertiary reaction. Don't forget that the tertiary reaction, they are having 2 steps of reaction. One is about the decomposition reaction and one is about the addition reaction. We can be say the reaction of secondary product, like that. Okay. We can be explain a small example. One of the small example. I think that the 2 examples we have, that small example you have to take written practice. These are not an important question. Try to take return practice. Okay, that's all enough. During the revision time, we can be learned thoroughly. Okay. Yeah, I'm taking one of the example, copper. All of you know about the copper metal. What is the symbol of copper metal? Cu. What is the usage of copper metal? Anybody know? What's the use of copper? Copper vessel. Okay, copper vessel. Next, in the wires, am I right? Electric wire having copper or use easily conduct electricity. Am I right? Okay, anyhow, what's the symbol of copper? Cu. Am I right? Cu. The copper reacts with nitric acid HNO3. We get copper nitrate. Am I right? What is the formula of copper nitrate? CuNO3 twice plus nascent hydrogen. Which hydrogen? Nascent hydrogen. I told you that the primary reaction, the releasing of nascent hydrogen. This is about the primary reaction. Yes or no? Primary reaction. What is the primary reaction? Metal reacts with nitric acid, we get metal nitrate, and also we get nascent hydrogen. Don't forget that this is the primary reaction. Okay, so how can you balance the equation? Here the balance equation is very, very important. Am I right? So how can you balance the reaction? In the product side, copper nitrate, if you are making 3 copper nitrate, making 3 copper nitrate means we get 3 CuNO3 twice. Am I right? Yes or no? So, how much nitrate they are having? 3 into 2 is equal to 6. So, we have to add 6 nitric acid. How much copper is there? 3 copper. So, make it reactant side also make it 3 copper. So, how much oxygen? You have to count the number of oxygen. Yes or no? It's check it that on number of oxygen. 6 into 3 is equal to 18. What about here? 3 2s are 6, 6 3s are 18. Am I right? So that also balance. What about the hydrogen? Here having 6 hydrogen, so make it 6 nascent hydrogen. Now the equation is balanced. Second reaction, I told that the nascent hydrogen reacts with some unreacted nitric acid which is present in the primary reaction. Am I right? Here I am taking the hydrogen, nascent hydrogen reactive nitric acid. First I am taking nitric acid, HNO3, that reacts with nascent hydrogen, gives enclosed in a square bracket. Am I right? Gives, we get nitrous acid. Nitrous acid formula, HNO2. And also, we get water molecules. Am I right? Water molecules, H2O. How can you balance the reaction here? Very easily, how can you balance the reaction? How much oxygen having the nitric acid? 3 oxygen atom. So, make it 3 water molecules. Yes or no? Okay. Now it is not balanced. Am I right? So first you have to make it 3 nitric acid means 3 nitric acid means 3 3s are 9. Yes or no? 3 3s are 9. And here water molecule is 3. The remaining 6 is needed. Am I right? So if you are making 3 means 3 into 2 is equal to nitrous acid. 3 into 2 is equal to 6. Okay, now the oxygen is balanced. What about the hydrogen? Here having hydrogen 6 product side 6 plus 3 9. 9 hydrogen having the reactant side 3 over the remaining is 6. Am I right? 6 plus 3 is equal to 9. Now the secondary reaction is also over. What about the last reaction? Nitrous acid, that is a HNO2. The HNO2 undergoes a decomposition. I told that the tertiary reaction, it may be decomposed or react to give final product. Am I right? First here having one of the decomposition. So nitrous acid undergoes react to form HNO3, nitric acid, and also we get NO. What is NO? NO means no, am I right? NO means nitric oxide. Nitric oxide. And also we get water molecules, H2O, water molecules. So, how can you balance the equation? Here having easiest way, hydrogen, count the hydrogen here, 3 hydrogen, product side 3 hydrogen, H2 plus 1, 3 hydrogen. So the reactor side make it 3. Now I think that it is almost balanced, am I right? Next we have to write the overall reaction. Overall reaction. What is about the overall reactions? We can be cancelling. Cancel which are the possible things, am I right? First you have to make it on line here. Okay, make it on line here. Which are the possible cancelling here? 6 hydrogen we can be cancelled because it is our opposite side, am I right? Reactant side and product side we can be easily cancelled. About the nitric acid, nitrous acid, we can be cancelled. Nitrous acid, 3 HNO2. 3 HNO2 can be cancelled. Then which are the possible here? Any other possible? HNO3. Okay, there is no possible, am I right? So, how can you six plus 3? Okay. Copper. How much copper is there? 4 copper. 3 copper. 3 Cu. Copper plus HNO3. 6 plus 3 in 9. Okay, here also there have one nitric acid, am I right? This if you are cancelling here means, here also we can be on cancelling here means, we can be written as 2 HNO3. So 2 plus 6 we can be 8 HNO3. Yes or no? Next, again which are the possible here? Copper nitrate. What's the formula of copper nitrate? ZuNO3 twice. How much copper nitrate is there? 3 copper nitrate. And about the NO, am I right? How much NO is there? Here having 1 NO. They are not balanced, am I right? This not balanced because here having 2 nitrogen, so make it 2 here. So you have to write 2 NO. And about the water, here also water is also not balanced, am I right? H2O, how much hydrogen is there? 2 hydrogen, H2, 3, okay, water is balanced. So 3 plus 1, 4 water molecules. So what is the final product? Copper, how much copper is there? 3 copper. And about how much nitric acid? 8 HNO3 gives how much copper nitrate? 3 CuNO3 twice and 2 nitric oxide plus also water molecules, 4 water molecules. Next one. Suppose the reaction is going as a concentrated nitric acid. Suppose we are adding one of the concentrated nitric acid means which are the possible product. Suppose constant nitric acid means the equal amount of nitrate will be produced. That means I am writing here Cu copper on reacts with HNO3, we get copper nitrate, that is CuNO3 twice plus NO2 gas. Don't forget that. And also we get hydrogen combines with oxygen, we get water molecules. Yes or no? That I think that you learn in the 10th grade. This reaction also have in the 10th grade. Copper reacts with nitric acid, we get copper nitrate. and the same amount of nitrogen dioxide and we get water molecule, same amount. Don't forget that. Here the product said how much nitrate is there? 2, am I right? NO3 twice, am I right, yes or no? So the same amount we are adding 2 means total how much in nitrogen having? 2 plus 2, 4. So make it the react side 4. Am I right? So how much hydrogen is there? 4 hydrogen. So make it 2 here. Now the equation is balanced. This is about the copper and about the magnesium metal. What happens to the magnesium metal? Once again, I am explaining about the same process with the primary reactions. Magnesium, that is about the magnesium metal on reacts with the nitric acid, HNO3, we get magnesium nitrate. What is the formula? MgNO3 twice plus hydrogen, nascent hydrogen. Am I right? So how can you easily make the reactions? Means here make it 4 magnesium nitrate means. Next we have to find the high nitrate. How much nitrate is there? 4 into 2 is equal to 4 into 2 is equal to 8. So make it the reactant side 8 nitric acid. How much magnesium is there? 4 magnesium. That is balanced. Next we can count the hydrogen. So they are having nascent hydrogen. So make it how much hydrogen here? Nascent 8 nascent hydrogen. This is the primary reaction. Why it is a primary reaction? Because having nascent hydrogen. Don't forget that. I will ask the question. Nascent hydrogen. Next about nitric acid, HNO3, that is the nascent hydrogen reacts with unreacted nitric acid. That's the concept. Nascent hydrogen react with unreacted nitric oxide in the primary steps. So give our reduction products. What is about that? Ammonia, NH3. Possible of ammonia and we get water molecules H2. How can you balance the equation? How the easiest way for balance the equation means nitric acid having 3 oxygen atoms. So the product side of water is make it 3. So now you count the hydrogen. 3 into 2 is equal to 6. 6 plus 3 is equal to 9. Already they are 1 over. So make it 8 nascent hydrogen. Now the equation is balanced. Next, third tertiary reaction, nitric acid HNO3 on reacts with ammonia NH3, we get ammonia nitrate NH4NO3. NH4NO3. Am I right? So the reaction is, I think, the balanced reactions. Next, we can write the overall reaction. What are the possible of overall reaction? Which are the possible of cancelling? That is 8 hydrogen can be cancelled. That is nascent hydrogen can be cancelled. Next about ammonia can be cancelled. Next, no possible for cancelling. Next, we can write the overall reaction. How much magnesium is there? 4 magnesium. How much nitric acid is there? Here having 8, here having 1 9, here having 1 10. So 8 plus 1 9 plus 1 10. 10 nitric acid gives, what's the expected product? Magnesium nitrate. There is a 4 MgNO3 twice plus ammonium nitrate formula NH4NO3 plus, here having 3 molecules of water. Am I right? So we write the overall reaction. Next one. If it is a very dilute acid means the percentage is about, I think that about the less than 5%, maybe like that, maybe 5% that we are saying very dilute acid. We get nitric oxide. Okay, sorry, we get nitrous oxide. Okay, we get nitrous oxide, one of the products. So you have to write what happens. Magnesium reacts with nitric acid. Magnesium reacts with Mg plus HNO3 gives magnesium nitrate. What's the formula? MgNO3 twice plus nitrous oxide formula N2O, and also we get water molecules H2O. So how can you balance the reaction? Already the previous reaction we wrote that one. Am I right? The overall reaction we wrote that one. How much magnesium is there? The above equation 4. So make it 4, 4. Magnesium is balanced. Next about nitrate. We are comparing nitrate here having 4. 4 into 2 is equal to 8. Here also nitrous oxide also having N2. For 8 plus 2 is equal to 10. So make it 10 here. What about the hydrogen? Hydrogen having the reactant side 10. So make it the product side also 5 into 2 is equal to 10. Am I right? Now the equation is balanced. Next about the uses of nitric acid. The first use is about that. We know that it is one of the uses about the oxidizing agent. What is the first use? Oxidizing agent. And one more point. And in the preparation of aqua regia. What is about the aqua regia means? Please note there. Aqua regia means 1 parts of nitric acid. 1 parts of nitric acid plus 3 parts of hydrochloric acid. This mixture we call as aqua regia. Aqua regia. Second one. It is used in the photography. That is about the silver nitrate. Photography. Silver nitrate. That is one of the nitrate compounds. Silver nitrate is used in the photography. And about the gunpowder. Gunpowder means, I think that the potassium nitrate. Okay. Potassium nitrate is used as the gunpowder. Firearms, one of the rifle, pistol, or other portable gun. These are all, everything is made up of, I think that about the sodium nitrate. Okay, these are the use of nitric acid. So, I am giving one of the assignment. It's a page number 62. Don't forget that the page number 62. Primary reaction. Secondary reaction, tertiary reaction. I think that this is one of the 5-mark question. Please try to learn at least the equation thoroughly. Okay. Thank you all of you. Thank you. Have a nice day.